Hi Mathspreneurs, greetings. We have done law number 1. Then we have gone on to the laws of indices and the laws of logarithms, and then the laws of indices or indices and logarithms, and now we are coming to law number 2. Alright, law number 2. Then after that there's a part A and a part B, but I'm going to separate out as per this video, which will be number 3. So we take A. We take the first power. This time around it is division. 1 on the left hand side, 1 on the right hand side. That's all. So we know when it's multiplied, the powers, the indices, the exponents add up. Now it's minus, so the exponents, the indices, the powers subtract in order. So the first one will subtract the second one. However, you'll see questions being set which look like here, this one. You have the same a to the power of m, but you see the a to the power of n coming underneath here. Same. Don't have to sweat it up. Okay? It's the same. Just to separate here, and then just to separate it here, and also here. Okay, you got that. But I want to tell you that the answer here is the same. Good. Meaning a to the power of m divided by a to the power of n is equals to a to the power of m minus n. A to the power of m, everything over a to the power of n is equals to a to the power of m minus n. They are the same. I want you to discover something along with me. I'm going to take you on a discovery tour. Let's use back a. We can even use 2 and all that. Make it a little bit bigger, will be easier on the eyes for a number of you who might have sight problems. Okay, with due respect, no offense. So a to the power of 3 divided by a to the power of 2. Look very carefully here. What is it? Simple. The powers just subtract. The indices just subtract. Don't call this exponent, yeah? Letters, then they call them exponent, as I've learned. Okay? So here a to the power of 3 minus 2 because a to the power of 1. So the answer is a to the power of 1. Now this is too easy for us. We are going to adjust a little bit and see what happens to the usage of this law. Meaning, I want to make this now a 3. What will happen? In fact, I'm scratching my head too right now. 3 minus 3 is 0. Woo! And what is that? Teacher, 1. Not true. Hey, sir, it is 1. It is true. Not true. Hey? You told in all the other laws? Yeah, I told in all the other laws. That's memorization or whatever. Here, at this juncture, allow me to tell you something. Yeah? Here. We went to this base. It had the power. The same base must be there. It had the power, another power. We went to this base. Yeah. So same thing over here. One base, another base, another base. The same bases. I mean the same base throughout, all throughout. And then we use this law, m and then n, that divide means just minus. So 3 minus 3 is 0. That's all. We do not have any other laws, my dear friend. Except that we have law number 1, which is here, times. And that will be plus. That's all. We are not having any times here. So law number 1 does not feature here, does not come into the story here, does not play it out over here. So we only have law number 1 and law number 2. But then teacher, you gave us, yeah, I gave you because fast students need it, you see, so I just gave it to them. Yeah, of course you must take care of the fast ones also, not only the super duper very weak, the written out ones. We want to take care of everyone who is humble and willing to learn and teachable. So they also want to know, they want to go faster, so I gave it to them. Now we are detecting some stories that are going to come out of this. What stories? We got stuck. Serious. At this juncture, we actually got stuck. We do not know. You cannot ask people, you cannot go and say or whatever. Nothing. We do not have any tools at our disposal. Tools at our disposal. I repeat, to solve this a to the power of 0, we don't know. But we have also, as I said, teacher, you are saying, I'm rich, I'm poor. Which are you? Or what are you? Are you rich or are you poor? Both. Rich and poor, you know, in one way, in another way, like that. So this way we have to yosi matri yosi. Think differently, think. Remember the thinking I was talking about? My friend from down under Australia told me. So we have to use this method, not the left hand side and the right hand side, but the top and the bottom, the numerator and the denominator. Aha! And see whether we can come up with an alternative to that a to the power of 0. Of course, common sense tells you, do not use back this law. Let this be independent on its own. They say in our local language, don't campur aduk with this, means don't mix with this. And let this one be independent. So using the local language, do not campur aduk here, means you do not mix with that. This means this, finish, story, end of the story. This means that, finish, end of the story. But somehow they are the same. But don't use this law over here, though you can. But don't. Why, teacher? Sir, why? Aha. Hold on. We are very close there. Okay? Here. So, I have given you a hint. We will be tempted to go and use back this law. Why not? We say that, we made the mistake, we are not careful, we simply go and use the law. That means we are just blindly, no offense to anyone, please cut that out. That means we simply go and then put the law. There is no use. Why? It is true. Nothing wrong with that. But you still get back 3 minus 3, which is a to the power of 0. So you get back a to the power of 0 is equal to a to the power of 0. Yeah, so good. But nothing. We cannot progress any further. We cannot proceed any further. So we have to yosi matri yosi. Think differently, think. We don't want this one. Okay? Now, allow me to delete with this eraser, this one. And I want to put 3 and 3. Okay, we go back to our blue. We go back to the 3 and the 3. Okay. Now, what is a to the power of 3 over a to the power of 3? You would say a times a times a over a times a times a. But not necessary. That's true, but you can just cancel. Isn't it? The same one you can cancel. And aha! That one right now comes out to be a 1. There, your yosi matri yosi, think differently, think, has actually resulted in something. The same question, left and right. The same question, up and down, numerator and denominator. The same question gave us a to the power of 0. The same question using not that law portion, but another way which we learn in standard 5, which is 11 years old, probably even earlier. The same over the same gives us this one, meaning we originated from here, ended up here. We also originated from here, a different version of it, and ended up here. We originated from the same one. Therefore, left hand side equals to right hand side. Can you please write that out? Therefore, the answer is a to the power of 0 is equals to 1. We have actually proven it through this simple example on the left and on the right. The left had a left portion and a right portion. The right had a top portion and a bottom portion. That's all. We have solved the a to the power of 0 mysteries. No more mystery now. Okay, so very easy. Wonderful. So very easy. So now we know why a to the power of 0 is equal to 1. Last time you were asking, then I said, sir, teacher, why? I said we will prove. So now we have already proven. The first law we have proven, law number 1. Now, law number 2. If you don't know how come the first law is, let's say you say, teacher, I still don't know the law number 1, how to prove. Very easy only. Just go and take a simple one. Law number 1. Just go and take a to the power of 3 and then times a to the power of 2. Easy numbers. Don't put 30 and 20 and write so many times. So what is it? So what is it? The meaning of a squared is a times a. The meaning of a cubed is a times a times a. Meaning we write this. The repeat, we repeat this. Oops, a daisy, I am. What is that? Well, hold on, please. Yeah, hold on. 1 minute. Yeah, 1 minute. Coming. All right, here. Let's see here. Okay, delete until there. Now begin. All right, a to the power of 3 is actually a times a times a. That we know. The dot representing the multiplication sign. Then here, to sort of differentiate a little bit, we go back to the times sign. That is the times here. And then a squared is actually a times a. So you go and see all together how many a's there are in totality or in total. In total, when you go and look carefully, you realize that there is a 1, a 2, a 3, a 4, and a 5. Meaning, that's how we got it as, which is actually a to the power of 5. And common sense tells us, how do we get the 5? The 5 is actually the 3 here for this one, plus the 2 there for the other one. That's all. So, don't have to go and break up. If you have 1,000, you don't have to go and write 1,000 times the a there. Okay, doesn't make sense. You just add up the powers, which is a to the power of 5. 3 plus 2 is 5. So is law number 1. So this law number 1 very, very easily proven. Okay, so it's so easy. That's it. Okay, we'll come back to the law number 2 onwards, using that to come up with some other discoveries and wonderful things. Seriously. Okay, now we are ready, and then we want to go to another one. Okay, now we are coming back to law number 2. You already know what is law number 2, but just in case, I will write back for you, which is what? A to the power of m. And then we want the left hand side and the right hand side dy. What I mean is what you see over here. Left hand side a to the power of n. Right hand side is a to the power of n, and then in between we put a dy. That's what we want. The answers are the same. For the next one, which is one upstairs, the other one is downstairs, meaning a to the power of m is the numerator, whereas the next one is the denominator. The answers are definitely the same, meaning the answer will definitely be the first power. Of course, the base is the base, no doubt about that. The first power subtract the second power. However, by looking at the previous example, we realize that for the left hand side, very important, yeah, please take note. I'm not rushing. You have to understand this. I don't want any of my students to memorize anything. You master it, you derive it on your own. Then anytime in the exam you get stuck, you can derive it on your own. You use this one for the left hand side. So I'm going to put here, for the left hand side, you use this formula. Okay, for the proving part. But for the right hand side, it is also this formula, but please do not use it. Use the standard 5, you know, the one which around 11 years old, the top over bottom. Meaning, I give you a sum right now. Okay, what do I mean? So, what do I mean? Like this, we go on. Just now we did a to the power of 3 and then we made the 2 first. Okay, first we had a to the power of 3. Then we have the dy. Just to remind you, okay, just to recall, okay, we are going to revise. So we had a 2 there. So 3 minus 2 is 1, very easy. Then we proceeded, we put a 3 there. This is when we sort of got stuck, which is a 3 minus 3 is equals to what? 0. Of course the equal should be there, I'm not writing right now. Then we said, don't use back this method, but use the cancellation technique, which means to say we have the a to the power of 3. You put over, of course you will be tempted to use the minus formula up there, the m minus n, but don't do that. Instead, be very aware. Pick up your eyes, open your eyes and say we are not going to use this method. Yes, this is correct, but we are not going to use this method. We are going to use the cancellation method, meaning I used another color. We are going to cancel straight away a 1. Cancel straight away a 1. 1 over 1 is 1. Aha, can you see that? So, you are 100% correct when you do this. You are 100% correct when you do this. They are the same answer. But for the purpose of proving, you use the cancellation method. So watch out here. Watch out! I used to tell that for my nephew's son and daughter and all that, all of them. And then they got used to it, and then they'll sort of make fun of me. Watch out! Watch out! Watch out, so you better watch out, yeah? Hey, not bad of an artist, yeah? Self-praise is international disgrace, sir. Teacher, self-praise is universal disgrace, yeah. Sorry, but I want you to focus on this. It's a simple thing. Focus on this, meaning a to the power of 0 is obtained by using the natural progression, the log. To do that, you come and use the log and you come back to the left hand side of the log. But for the right hand side, you don't use back the same thing, or else you still come back to the left hand side. You want to come to the right hand side. How? You divide. You do this division. Divide top by bottom as far as you can. What do I mean by as far as you can? I maintain this and bring a green one in and show you as far as you can. Meaning, I'm putting a. The 3 is gonna be fixed. You're gonna fix the 3. Divide is still the divide. Remember the first one I put 2? Yes. Oh, fireworks still. Now it's coming to the last week or so of Shawwal. Eid ul-Fitr. Eid al-Fitr. I saw at the bank. Ideal Fitri. See, they're still all peaceful and everything. This is how we want to be. Be peaceful, yeah? Run away from hate and fighting and killing. Nobody wins. All lose. Here, everybody wins. They are happy, we are happy. Nobody fights. So, okay, remember that. And then here we increase. So what I'm telling is I put a 2, we know 3 minus 2 is 1, no sweat. Then I put a 3, 3 minus 3 is 0. Oh, got problem, come over, don't use this part, but use the cancellation. 1, so left must be equal to right because we came from the same question, only in different format. Here we are going to use the division method to prove something. I just increase here. What happens? This one, I will give you the working. One step. Of course, most of you would have already known it, but I show you the working. Which are we using? Definitely we are using this for this one. Okay? But take it off and it gives us an A to the power of 3. Take away 4 cannot. You shake your head. Left to right, so left to right, left to right, left to right. Let's take the big one. Don't want the negative now. Taken care already. Taken care of already. So 4 minus 3 is 1. Teacher, I know this sum. Yes, because I gave you the formula. Sir, I also know this sum. Yes, because I gave you the formula. But if you have not been given any formula, a newbie, a newcomer, a freshie, a fresher, they call it in some countries, in one country. So, a sophomore or what? You don't know this, so what to do? No help, you know. So definitely this part is bringing you to the left hand side and putting you in a quandary, Q-U-A-N-D-A-R-Y. The left part is very good. We are using the formula, but it's putting you in a quandary, Q-U-A-N-D-A-R-Y. Not quandary, yeah? Hey, that reminds me. Slightly off, huh? What is this? I used to read this as O, R-Y, and then this is re. So I used to read this as ori, ori, ori. Ooh, I was proven wrong 100%. It's actually a rye, Ooh, so bad. I felt humiliated, but not in public. Simple thing I don't know how to pronounce, and I want to teach English. Hey, wait for my English course, yeah? It's gonna be so helpful for those who don't know English. Serious. Just because I don't know one word doesn't mean that I cannot teach, isn't it? So it's negative thing. I told you the wheels on the bus go round and round, round and round, round and round. The wheels on the bus go round and round, all through the town. Go vertical, and this one is the like a negative, like a division put there. That's what you said. That's what I gave in the formula. But it's not there for us. You have to prove that that is true. How? So we use back this method upstairs or downstairs, but don't go back to the formula. Go back to the division. Got it? Repeat. We are going to use the top over bottom, the numerator over the denominator, and we are going to quickly be very alert and come and use this method, the cancellation method. Of course, this is true. We don't want to use it because it's already there and it got us in a quandary there, so to speak, a quandary there. But it's nice answer. Correct answer, correct answer. So we want to get this part of the answer now. Focus on this. On the right hand side, you see this one is exactly equal to that. A to the power 0 equals to 1. So now we are going to find out, like I told you just now, that a to the power of minus 1 is equal to 1 over a. But how? How? Why? You tell me why. How? You also tell me how. That's the first time I'm saying like that. So we use the over method. Okay? Is it okay if I delete this so that nothing disturbs you? No need. Keep it there. There's something there to refer. Use another color. Color. English teacher wannabe don't know how to pronounce color. Yeah, right. Okay, yeah. So what is the division method that I am talking about? Very simple. Don't go back to 3 minus 4 and then minus 1. It will end up on the left-hand side, that result we don't want. We want the right-hand side, the right-hand side result, which is you put top over bottom. That's all. And then you do cancellation. Teacher, how to cancel a to the power of 3 over a to the power of 4? Sir, I don't know how to cancel, a to the power of 3 over the other one, a to the power of 4, how? Straight away can cancel. But if you don't know, I take another color. I think this time I really need the green. Okay? And show you here. You can do slowly. A times A times A. That's 100% correct. That's A cubed. Then a to the power of 4 will be a times A times A times A. The first 3 will cut off. It will be 1 over A. Yeah, that's how we got. Another way is again, you see, matri, you see. Think, differently think. Thinking. Use your thinking caps, okay? Put on your thinking caps. If there's an A3, try to pull out A3 from the 4. Can. Teacher, but it's not equal. Yeah, so you make it equal. Of course, the power 3 is not equal to 4, correct? But you make it equal. How? Thinking again. Thinking again. A to the power of a 1. That's all. No sweat. Why did we do that, teacher? Sir, I also know. Very good students. You all know, yeah? Very good. The reason we did that is that the same like this. A to the power of 3 over a to the power of 3 is cancel 1 like that. So a to the power of 3 cancel is 1. How do you know? Because that thing is a 1 there and that thing is a 1 there. 1 over 1, no sweat, nothing. So it's just a 1. So the final answer I'm doing on the left, please, yeah? From this portion here, I'm coming here. Please understand. No space there. And then I want to put here. The answer is actually 1 over. Aha! A. And then teacher, what happened to the 1? No worries, isn't it? Delete because no space there. I want to take this up a bit. Yeah. And that will give us more space for the A down there. So it will be 1. And then this will be over, and then it will be, hey, teacher, there's a 1 there. Yes, but the 1 there is not a problemo. Why? Just put the 1 down there, that's all. But who puts a 1 there? Not necessary, isn't it? Here also there's a 1, I told you. Not necessary, isn't it? So no need to put a 1 in front, the coefficient 1. Then no need to put the 1 up there, the power 1. Understood? Aha. The wheels on the bus go round and round. See here, the minus is actually 1 over. Now we have proven it. Wait. Now we have proven it. Are we sure? Yes, we are. It's like this. We did on the left hand side, we came to this answer. We did on the right hand side, we came to this answer. Then we equated the two. We can even put like this, equal. A to the power of 0 equals to 1. Same thing here. We did by using the formula and we sort of got stuck. But it's a happy getting stuck here. Why? Because we came up to that answer at the very least. If you don't know, you can put this and you'll still get marks. Okay? But I would expect you to go this if I were an examiner. How? We use another way of thinking, reasoning, which is put 1 on top and 1 below, numerator, denominator. And once we did that, hey, we got a 1 over A. Therefore, we came from the same ori. This is the original. This is also the original. Believe or not? Better believe, huh? Yes, sir. Yes, teacher. So a to the power 3, a to the power 3. Divide. A to the power 4, a to the power 4. So we came from the same ori. That method using the minus thingy came to this. This method using the division thingy came to this. Ori came to here, Ori came to here. I go left hand side, I use one road, I came to the city center. I use another road right hand side, I go there, I also came back to the city center at the same spot. Haha. I want to meet you, let's say. So I met you. So this answer is 100% the same as this answer. Repeat. What do you mean by repeat? A to the power of 0 is equal to 1, and then a to the power of negative 1 is equal to 1 over a. Then I told you if there's a 1 there, you put a 1 here. Got it? Use different color. If there's a 2 there, you put the power 2 there. Meaning the 1 over is just for the negative only. Okay, take that away and take it away. Good. If there's a 70 there, nobody gives you that. I give. There's a 70 there. We are coming by the law of induction. Yeah. 2 lines will be okay. There will be deduction, but then we go induction. Top, 5 steps, 6 steps. We see the same pattern coming in. Then we say, if we have a million times, we put back million there. But in this case, we don't have a million. We have a what? We have an and there. So that is the next law that we have gotten there. So we put an and there. If it's not very visible, the black will do the trick. Yeah, that's very visible. If this a to the power minus n, very simple. This minus thingy is only the 1 over. That's it. The minus thingy is just 1 over. And then all the rest, you see the a and the n. You see the a and the n. You just write back. Woo! Woohoo! Woohoo! Different ways of saying the same thing. Do you realize something? That use big one. Okay? Bigger one. It's too big. We use this one, okay? Big one. That we have used the laws going the left way, going the right way, and then we found out one extra result of indices. Ooh. Then we use the law to find another result. What's that thing there? This one, you know. Ooh. Which is that one, and that one actually turns out to be this one. In other words, allow me to write somewhere here. Meaning a to the power of negative n. I'm going to cut across here. Don't focus on any other color. Okay, focus, zoom in on this color, this color, this color, this color. I'm going to put here a. I'm going to put here the power n. I'm gonna put there a negative power. Ooh. Because pink color is already there, I'm gonna go for the green color. Good. Go back to this color. What is the meaning of this negative here? Is 1 over. Very easy peasy. What's the meaning of this negative here? It is 1 over. And then all the rest that you see, you just write it down. Fireworks, celebrations, and congratulations. A, I see. Oh, I see. And I see, we see. So that's all. So the first result we got was a to the power of 0 is equal to 1. Then a to the power of negative n is equal to 1 over a to the power of n. Ooh, no joke, you know. In this case, we can also introduce something. If there is a, let's say, if this time is 1 over, negative 1 over n, then here will also be 1 over n up there. Then you can go and n through it. You know what I mean, isn't it? Okay, you know what I mean, isn't it? There, here, you just put a over 1 over n, a to the power of 1 over n, then it's the nth root of a. Ooh, nth root. That's the meaning of it. Now let's take that out and make it even more interesting. What happens if we put M over N? Of course, this one will come to the center here, understood? So here also we put M over N. And then that one has two variations there. Ooh, no joke. We have actually finished all the laws in this page itself. But I will continue in the next one. I'll draw one more. Of course, it's 1 over a to the power of m over n, which will be the nth root of a to the power of m, or everything in bracket nth root of a, everything in bracket the m down there. But of course, the 1 over is for the negative. Anytime you see the this negative sign is 1 over. Anytime you see the negative sign, it is 1 over. Anytime you see the negative sign, it's 1 over. Then the power there is negative, it must be 1 over. When the power there is negative, it must be 1 over. No doubt about that. Whoa, thank you. I hope that you will be able to stand on your own 2 feet without depending on memorizing anything, okay? Or depending on anyone except yourself, where you will yosi, matri yosi, think, differently think. You go into the thinking process. You create, you innovate, okay? But get the correct result. God bless each and every one of you to score your much desired A star, A asterisk, A1, call it whatever it is, distinction, okay? God bless each and every one. Go score.